Hello, I guess this will be a video on the use of collectors and relays within equivalent exchange version 6. I'm not sure how well this is going to stand up in the future, and all of this is test data. This is not looking at source code or doing any math like that. But basically, let's get started. So, Tech1 collector is going to cost 83,000 EMC, and it's going to produce 4 EMC a second. Tech 2, 232,012, and Tech 3, 448,024 EMC a second. These numbers are from basically emptying it out, hitting play and letting it run for an amount of time and then figuring out the rate. So all of these test at those speeds. Now, the actual purpose of this video is determining peak efficiencies for proximity bonuses and what builds and what flower types you should use. There's been a couple suggestions in other videos of this design, which you can see off in the distance there, which is quite common, but we'll get back to that in a sec and why I don't think that you should do that. So what I did here, just to figure out all of the proximity bonuses, is I took all of the Tech 1 relays, the Tech 2 relays, and the Tech 3 relays, and I paired them up with the Tech 1, Tech 2, and Tech 3 collectors to make all the different combinations. And after some testing I found that it doesn't really matter what collector is connected to a relay. All of the proximity bonuses are based solely on the relay. So if you have a Tech 1 relay, you're going to get 1 EMC a second bonus, and that is basically for this relay right here. There's one block touching it, so it's going to get an extra 1 EMC a second. For a Tech 2 relay, it's going to have 1 block touching for a bonus of +3, and for the Tech 3 collector, Tech 3 relay, you're going to have a 6 EMC a second bonus. And that seems to be consistent throughout whatever kind of collectors you're using. So, now, if you double up the number of sides they're touching, you're going to double up your bonus. It's pretty straightforward. However, if you ignore the fact that there has to be full lighting, you will actually get a penalty. This collector at the bottom is not receiving full power. So while you do receive the actual proximity bonus on the relay, the collector's power output is lowered such that it actually ends up being 1 less instead of 1 more. So this is actually a 2 EMC a second penalty, but it's a net difference of 1 EMC a second compared to a single collector. So again, this has the same problem with it. So this is the improved version. If you're going to do this, you put tops and sides are good, top, sides, and back and front are also good. But again, if you're going to do this, where you're going to have five relays and 1 collector, you don't put it on the bottom, you put it on the top. Rather, don't leave your axis face on the front, put your axis face on the bottom. Then all 5 of your collectors are going to be operating at 100% efficiency, and you'll get your proximity bonus 5 times without your collectors having this penalty down here. So what I was saying before is this seems to be the most suggested layout, I guess. All of the videos and the wiki all suggest either this or something similar. The wiki actually suggests... one second. The wiki actually suggests this layout, where you have your axis at the top. This is exactly the same. Actually, this is less. Well, depends how you measure it. This is basically, again, not as efficient as having your axis on the bottom. So if you can, you want to leave your top closed, because all of those are going to be running at full speed, and where you want to get your access is going to be through the bottom here, because it's this one relay that was in the spot that is going to be your your least efficient spot. So if you can remove that, you'll be getting more energy. So moving along, I noticed the penalties, and I wanted to just check how they work without the different levels and different levels of light. So what this is all three types of relays on the same type of collector, in case all three of these are Tier 1 collectors, and then Tier 3, Tier 2, and Tier 1 relay. The purpose for this was to measure the light penalties. So when you take the relay that should here be producing 4, and the collector that should be producing 4, and this relay that should be giving you a bonus of 1, you should be getting 5. However, you actually only get 3, so there's a penalty here of 2. Again, from what you'd expect, you end up with a penalty of 1 and no penalty. So this is basically, I think of this as full light, this is partial light, and this is minimal light. But for each step up in the technology, your penalty is reduced by half. And this is consistent, but scaling. So if you have a Tech 2 collector, the cost of not being perfect is higher, so your penalty is 6. If you give it medium light, you're going to have a penalty of 3, and if you give it full light, you're going to have a penalty of, well, 0. And then again, the highest penalty here is going to be incurred on a Tech 3 collector, where it's going to be actually losing 11 full energy. So you really want to avoid this if you can. You want to, it's actually better to take this off and let it run at full capacity than to put the collector on top. The collector's bonus is negated by the lack of sunlight. So anyway, you can take that into consideration in your designs. Again, half penalty and no penalty, so this is obviously the best. Now, there's a couple different misconceptions that people seem to have. So one is that you, well, at least when I started out, I hit Tier 3 and I was like, yeah, that's awesome. And I immediately went out and I thought that, you know, the bonus is going to be great, so I put up my Tier 3 relay and I put up my Tier 3 collector. This here is actually the single worst pairing and least efficient way that you can build energy generation. And the reason for that is that you've now spent 500,000 on this one collector, and you've spent another 80,000 on, 80,000 on the collector, 500,000 on the relay. So you've spent 600,000, and your generation here is only going to be, one moment while I check on another screen here, the actual numbers I have on it. So you spent 500,000 here, and your actual generation a second is just 10. So ultimately that means that you've spent 51,000. Let me go find that little section of things that I made. Yes, it's over here. Okay, so this little thing here means that for each unit of energy generated, you have spent 51,000 EMC. So this is generating 10, you spent 500,000. 500,000 divided by 10 is 51,000. Another way to interpret this number is it will take 51,000 seconds to duplicate this array. So, by comparison, this array here is similar to what is over here, where you've got a Tech 3 relay and a Tech 1 collector, except you've added some extra collectors. Now there's still Tech 1. We're not changing the technology of the collectors at all. We're simply adding 5 more collectors. But by adding those 5 more collectors, our price to build this goes up from 511,000 to 926,000. We spend an extra 400,000, but our energy output goes from 10 to 60, and that's all based on our proximity bonuses. So proximity bonuses in this game are key. You can see the numbers here are just flying up. I'll just spin this off on my client star, but you can see here we're getting a good amount. It works out to about 60 a second, so 1, 2, 3. So it went from 300 to 420 in 2 seconds there, approximately. And all of that test data is averaged out over 30-second intervals, so the numbers should be pretty accurate. A slight modification here is if you build this if you build this flower with all Tech 3 collectors and a Tech 3 relay, as you'll see in here is the Tech 3 relay. Obviously you're going to get higher production. In fact, you get 3 times the energy production of this. This configuration is going to give you 60 a second at a cost of 926,000. This is going to triple your production. You will get 180 a second. However, your cost is more than 3 times as expensive as this. So the cost on the right one here is 926,000. The cost on the left one here is 3,120,000. So that's why the difference in these efficiencies here. So this one will take 15,000 to duplicate. This one will take 17,000 to duplicate. So the moral of this little story here is if you've got 3 million to spend, instead of building this configuration here, where you've got the 6 Tech 3 collectors, go for this one where you've got 6 Tech 1 collectors, 1 Tech 3 relay, and then build this star 3 times. It'll end up costing exactly the same as this, but you'll end up getting about 30% more output power per dollar spent, or I guess per EMC spent. And this is basically the key little idea of this whole video is that you want to get lots of tier 3 collectors with covered in Tech 1. Sorry, let me restart that. You want to get tons of Tech 3 relays covered in Tech 1 collectors so that you get as much relay proximity bonus as possible. And that's really going to be the key to this whole idea of getting your maximum efficiency out. And because everything in equivalent exchange builds on itself, the faster you're generating mass, the faster you're going to be able to generate mass, and the faster you're going to get up to higher things like dark matter and whatnot, the faster it's all going to go. So these 3 together here are obviously going to give you, basically, this star costs the same as these, approximately. There's a little bit of a margin in there, but it all works out that these 3 will produce the same energy, but cost less. And it's about 20%, so yeah, I hope that this has been informative. One other little comment I'd like to throw in here before I end this video is, again, because you're chasing after relay proximities, build your stars in proximities. There's no reason to do what I did here and separate them. I just did that for video purposes. But if you want to build more relays in one little area, build it up in 3 dimensions. So start from the bottom. I'm just going to basically alternate collectors and Tech 3 relays. Sorry, Tech 1 relays. So this is a very simple example where you've basically merged 2 of these into one. We've saved the cost of one Tech 1 collector, but we're still getting all the same proximity bonuses. This one in the middle does not produce any less of a bonus for the collector that's in the bottom and the collector that's in the top. So this collector up here is still getting its 6 bonus from this, and this one in the bottom is also still getting its 6 bonus from this. But now expanding that from 1 dimension, or sorry, I guess from 2 dimensions to 3, since we've already got all of these nice little U shapes, we're going to fill these in with Tech 3 relays, and then we're going to fill in all of these little areas with a Tech 1 collector. So the point of all of this is to get as many proximity bonuses as possible in a small little space. You can't build any larger than this with a single Kleinstar because energy will not flow from a relay to a collector that doesn't have a Kleinstar in it. So basically, this is as big as you can build them. After this, you have to start putting, making separate ones. But so we're going to put this in the bottom, throw a Kleinstar on the top, and again, you'll find that we're getting huge amounts of numbers out of here. This should basically amount to... actually, I haven't clocked it, but let me just quickly do some math here. We're going to get 1, 2, 3, 4, 5 proximity bonuses for each collector we have. We have 5 collectors, 5 relays. 5 proximity bonuses per relay. Let me rephrase that. We have 5 relays. So we're going to get 25 proximity bonuses of 6 each. 25 times 6 is going to be 150. So we're getting 150 bonus energy out of this relay per second. We also have 4 collectors in the bottom, 6, 7, 8, 9 collectors in the middle for 13. 4 on the top is 17, and 1 on the top is 18. So 18 collectors is going to also provide for us 40 and 32 is 72 on top of our bonus of 150. So all of this should be generating 222. That's not bad. So let me just take a look and so yeah, that's doing approximately 2.25 a second. And yeah, so basically my suggestion is if you want to get started, aim towards this structure right here. And you're going to need, again, 5 Tech 3 relays and 18 Tech 1 collectors. Anyway, bye. Hi, I just thought I'd throw this in here. This is a screenshot of all of the prices of different things. Followed by the cost to build arrays. Here, this is a start. So in the bottom right, you can see it's 3 million to build 1 relay and 6 collectors. This is how much power output you can expect that configuration to be. So again, in the bottom right, that's 1 relay surrounded by 6 collectors. This is the amount of EMC spent to generate 1 EMC per second. And this is the relative efficiency of doing it that way. So you can see up in the top right, obviously, at 0.00647% efficiency. That means that for if you spend X amount, you will receive 0.0064x per EMC per second by doing it that way. So this chart is basically meant to just say that 1 EMC per second, or sorry, 6 Tech 1 collectors and 1 Tech 3 relay is the most efficient in this chart. Anyway, thanks for watching.